Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amirul Izani Bin Mohd Ridzwan. Today, I would like to present to you about my final year project proposal. So, in this video, I would like to explain more about project summary, introduction, literature review, problem statement and objective, scope and limitation of project, methodology, and expected result. Project summary. In this project, the crushing behavior of different type of cylinder tubes such as simple tubes and window tubes are investigated. It will be done by laboratory experiment and also by simulation. Introduction. In automotive industry, thin wall structure is widely used as energy absorber. As we can see at the car, thin wall structure is designed at the bumper of the car to absorb energy. It is essential to design a system of thin wall structure that provide the maximum protection against impact force when the vehicle collide with each other. It is to ensure the safety of the people in the vehicle. The crushing behavior was widely studied by different type of loading condition such as dynamic, axial loading, bending loading, and also oblique loading, where they have an angle when crushing the tubes. Literature review. In the previously researched Hamid Nika et al. 2017, the crushing response of tube with different types of windows tube under axial and oblique loading. The tubes that considered in the research is square in cross section, and the geometry that will be investigated is circle, rectangular, square, hexagonal, convex, and ellipse. So the result show the difference between simulation data and experimental data for each tube is slightly differs to each other, and the data of simulation is acceptable when compared to the experimental data. The tubes are deformed axially. For the angle loading or oblique loading, the tubes deform axially, but there have some tilt deformation according to the direction of the angle. It is shown that the initial peak crush force PCF of window tubes are lower in value than the simple tubes, but simple tubes give or provide larger value of energy absorption. To be compared among the window tubes, tubes with circular holes have the largest value of energy absorption at all angle of loading except at 0 degree, where square holes have the largest EA, which is energy absorption. In the next research of Hamid Nika et al. In 2019, various cutout geometries were introduced to the thin wall tubes, with also various cross-sectional shape to be studied. There are 3 tubes with cross-sectional shape, which is circular, hexagonal, and square, with 3 different hole shapes, which is circular, hexagonal, and also square, were evaluated in the research. So, the results show that the deformation of simple tubes are more symmetrical than window tubes, as window tubes have a material discontinuities and simple tubes are more uniform. With the best combination of specific energy absorption SEA and peak crash force PCF response, the circular tubes with square window at the side wall of the tubes was chosen as the best tube in the study. According to the research, the ideal tube is one with larger size of window or holes in the side wall of the tubes, and more windows in the horizontal direction, and also fewer holes in the vertical direction. Another research by Subham Butada and M.D. Goyle et al. Show that the use of different geometrical modification in tube structure will significantly develop its crushing characteristic. So in this research, there are 3 samples of window tubes. So for the tubes 1, 12 cuts out are positioned in a single line at a distance of 5 mm from the impact end of the tube. And for sample T2 and T3, 6 cut outs, which is windows shape of holes, are positioned in 2 rows, 5 mm and 15 mm from the impact end of the tube respectively. But for T2, the cutouts will position in aligned patterns, while for the T3, the cutouts will be in staggered patterns. So the results show T2 has a higher crush force efficiency and lower peak collapse load, which is peak crush force, than tube T. Tube T is simple tube. As we know, simple tube will give a higher peak crush force and also higher energy absorption than window tube as the previous study. So tube T2 configuration or patterns of window holes provide the nearly optimum mean collapse load, which is average peak crush force and energy absorption values among all the 3 specimens T1, T2 and T3. So it is observable that the presence of discontinuities like cutouts or holes in the tubes has a substantial impact or effect on where the buckling occurs in tubes. Due to the loss of materials, which is the cutouts, the cross section where the cuts out are created or positioned at the tubes will become relatively weaker, so that the buckling will be occur at the holes, as it easy the tubes to be crushed. Problem statement. Energy absorption of a structure is essential to absorb impact force during a collision such as car accident that will affect the driver or the passenger in the vehicle. So the crushing characteristic of the circular tube is studied to provide a good crushing behavior and to study about the crushing characteristic of the tubes when the tubes is crushed. As we know in our literature review, simple tubes will provide an interesting crushing or energy absorber behavior, and it's also provide a high peak crush force. So in order to give a good structure of tubes, so we look to the objective of our study, which is first to improve performance of energy absorption for circular tubes. Second, we need to finding a solution to reduce the peak crush force and initial crushing strength. And third, we want to design the collapse or buckling structure of thin wall circular tubes after the impact. Scope and limitation. In these studies, it will be conducted by using three types of samples. First, circular cross-section simple tubes. Second, circular tubes with circle window shape. And third is circular tubes with rectangular window shape. So the sample will study its crushing characteristic by experimental in the laboratory or simulation by using software. Then the data such as initial peak crush force, energy absorption, and also the shapes of the deformation of the tubes can be gathered and will be compared to each other, and we will be choose where is the best design. Methodology. So first, we need to prepare the sample first before we conduct the study. So we need to prepare a circular tubes with window shape, circle and rectangular, including the basic circular tubes with no window shape on the side wall. Then we will conduct the study using simulation methods. So in simulation methods, the sample will be designed by using CAD software such as CATIA or Abacus, and will be analyzed. And then we will validate the data from the simulation methods by using experimental methods. So in these experimental methods, we need to fabricate first the tubes in the workshop, and then the sample will be conducted in the laboratory using crushing or impact test machine. And then the data will be gathered, and the best structure will be choose or selected based on the data that gathered in the experiment and simulation method. Expected result. As expectation, all the tubes will deform axially as we studied for the dynamic axial loading only. And then simple tubes will deform more symmetrically than window tubes. Window tubes will provide a lower peak crush force than simple tubes, but simple tubes will give a better and larger energy absorption than window tubes. Then the last, the comparison of simulation and experimental data will have a slightly significant difference with an acceptable percentage of error. So this is my references.